Hello AP Calculus students, this is Mr. McAllen, and today we're going to talk about finding antiderivatives. And we're going to first start off with finding general antiderivatives. If we're given a derivative and we want to work backwards, we have to learn how to do the reverse process. So we're going to do that with polynomials first, then we'll do it with functions that we should have memorized by now. And we're going to talk about them being general, and then we're going to talk about how do we find specific antiderivatives if we're given a point that the functions pass through. So in class what we did was we talked about how do two functions that have the same derivative, how can you have two functions that have the same derivative? And the answer to that question is you can, because let's just say that one function is a parabola, and you have, so let's call that f of x, and the other function is a parabola, I'll call that g of x, which is just f of x moved up by, let's say, 5 units. These two functions should have the same derivative. For example, does, if f of x equals x squared, does g of x have the same derivative if it's x squared plus 5? And the answer to that question is yes, it does. F prime of x is 2x, and g prime of x is 2x. So the answer to the question is if two functions have the same derivative, then they differ by a constant, and that's actually a theorem or some sort of a rule in calculus. So if two functions have the same derivative, then the functions differ by a constant. So how do we use this practically? Well, first thing is if we have, let's say, f prime is equal to let's say 3x squared plus 2x plus 1, and they want us to, or somebody wants us to find the antiderivative, we have to do the reverse process. And the reverse process basically is if you have this is for a power function, if you have a function that is ax to the n, and this is the derivative, then to go back to the function, you would add 1 to the power, because when we differentiate we took 1 away from the power, and you would divide by the new power value. So basically this is the formula for it. We can check that by taking the derivative on it, and if we took the derivative of this, the n plus 1 would come down in front of a, and then you would have a to the n, you'd reduce that by 1, and you divide by n plus 1 that was there before, so you'd be back to the original function. So let this be your rule for a polynomial function or a power function. So now for this term, to find the antiderivative of that, I would have the 3, pardon me, I would raise the power by 1, and I would divide by that new power, thereby eliminating that coefficient. I wrote up this polynomial special so that it would work out nice for me, so I wouldn't have too many fractions. The next one, I have 2. I raise the power because it was a power of 1. I'm going to raise it to 2 and divide by the new power, and that's going to be x squared. And then this one, x to the first, I'm sorry, this is the number 1, so this is going to just be x to the first power, because it was x to the 0 before, which was a constant, so raise the 0 to 1, it turns into 1 over 1, that cancels, so our polynomial function is going to be x cubed plus x squared plus plain old x, but don't forget that when you antidifferentiate, you always have to put plus c for the constant. So this is how you find the antiderivative for, or the general antiderivative for a function. Now, if they asked you to do, let's say they said, you have a function that is not polynomial, now you need to, let me call that g of x. Let's say, for example, this is the sine of x, maybe plus the cosine of x, maybe plus e to the x, maybe plus, all right, let's say tangent squared of x. These types of functions don't have rules to go backwards. You have to remember what you took the derivative of to get there. So when you find g of x, the anti-differentiation process is just thinking, well, what did I take the derivative of to get sine? Well, that was negative cosine of x. And it's always good that once you write this down to take the derivative and check it out again. And the next one would be, I took the derivative of sine of x to get cosine. I took the derivative of e to the x to get e to the x. And I took the derivative of, well, tangent, I should change this because there is no, I meant to do secant squared of x. There is a way to do tangent squared of x. We just haven't learned that method yet. It has to do with doing some substitution, and we're not there yet. So anyway, so now secant squared of x would be just tangent of x. My apologies. But and then you got to put plus c. So now, I also had a problem. Sometimes we're asked to find the specific antiderivative or solve for the constant. So they might say if f of x is equal to, I'm going to use the problem from before. We had 3x squared plus 2x plus 1, 3x squared plus 2x plus 1. If that's your derivative, and it pass, and they say, you know, find the function that passes through a point. Oops, spell that right. Let's say 3, 2, just some arbitrary point. So now we want a specific function that passes through a certain point. So this is where we're going to use that condition to actually solve for the c constant. So the function anti-differentiating is going to be x cubed plus x squared plus x plus c. We did the anti-differentiation process to get here, and now we use that initial condition. That's the y value, that's the x value. So I'm going to put 2 over here. I'm going to have 3 cubed plus 2, 3 squared plus 3 plus c. And I'm going to solve for the constant. So now I've got 2 equals, that's 27 plus 9 plus 3 plus c. So then that's going to be 2 is equal to 39 plus c. My constant is equal to negative 37. So my equation they're asking me to find, f of x is equal to x cubed plus x squared plus x minus 37. Now, the reason why I'm rushing through all this, we found the constant, we put it in the original equation. You should always check your function to make sure it works. For example, if I plug 3 into this equation, I should get a value of 2. So if I put 3 in, I cube it, and I square it, and I add it, and I take 37 away, I am going to get 2. So that checks. And the other thing is, to make sure I got the right antiderivative, is I should take the derivative of it to just make sure that I didn't make any silly mistakes. And if I took the derivative of this, you would clearly see I have 3x squared plus 2x plus 1, and that would match up with what my initial given conditions were. I hope this video helps you understand how to find the general antiderivative and also how to find a specific function when you're given a point condition. I look forward to hearing your comments, and please comment on the video or email me any questions you might have.